Hi, I'm Jennifer with the Kentucky Agriculture and Environment in the Classroom, and this is our Down the River activity, which uses engineering and design and also talks about some physics to understand how important our rivers are for moving our agricultural products around. So the task here is for the students to design a boat or a barge type structure to be able to hold a pre-measured quantity of, these are marbles, we're going to pretend it's grain. Because here in Kentucky we have a lot of waterways, and it makes it very convenient for our agricultural commodities and the farmers to move their product around. They can travel by river, which is much more efficient than rail and truck, and then eventually they can go down the Mississippi River and end up in markets all around the world. So when the kids come up, we can show them pictures of a truck, a train, and also of a barge. And first we're going to ask them about transportation. Which one of these do you think is the most energy efficient, or takes the least amount of energy to move our agricultural products, our farm products? And you may get some different answers, but we want them to understand, because a boat is on the water because of buoyancy, the water lifting up on the weight, that grain and other agricultural commodities can move more efficiently down the river on a barge. We have a nice graphic here that one barge can hold 1,500 tons of cargo, but when a towboat's attached, it can move 14 barges at once. It would take 15 rail cars, that would be the same amount as one barge, or 58 trucks to be able to move that same amount. So if you're talking about how much fuel it takes to fuel each one of those, obviously the barge is going to be the most efficient, and it's going to be even more efficient if it's moving downriver, so the current is going to help it even further. After they understand that, it is going to be their task to design a boat that will hold the grain. So you're going to give them about 2 minutes. Every child gets a piece of aluminum foil that we provide. Give them 2 minutes to create a boat. So we've got 2 examples here, and once the first student is ready for it to be tested, we have this blue bucket right here is half full with water that we've provided. We're going to set it on the water, and then the next thing is we're going to test to see how much it will hold. Depending on the boat shape, I would try to help them out as much as possible by laying it in there where the weight is distributed, so you're not going to, put most of it on one side and then it's instantly going to sink. But we're going to kind of help it out the way that we lay it in there, and every child gets a turn to test their boat. The goal is that it has to hold at least one baggie of grain. So this boat design did that. Then we're going to test a second one, and you can kind of place it in there strategically, not to sabotage it, but it didn't hold 2, it instantly sank. But the fact that it held 1, that's good, because that was the goal. So you can set that in this extra bucket so you don't get too messy. So here's one that's more like a barge. So we'll try this one, same way. We're going to place in the grain, and it was top heavy and it didn't work. So once you've tested everybody, if they didn't meet the goal, you can have them go and rethink their design and do it again. So we may make some modifications here to make it a little sturdier. And a lot of it is kind of how you set them in there to help them out. So we're going to try it again. And again. So this one's going to need some more work. We have a leaderboard, which is called Down the River. So the goal is to get 100 grams, but if they get 2 bags, That's 200 grams. They get to place their name on the 200 gram leaderboard. And we occasionally have students that their boats are able to hold 300 grams, so then they can place their name on the 300 gram leaderboard. So obviously I need to go back to the drawing board and redesign my boat because it was a fail this time, but that's kind of the fun of this, is learning how to create something with physics in mind, to test it out, and if it doesn't work, they get to rethink their design and do it again.